welcome back. So hopefully you took this time to complete number 10. I went ahead and labeled it myself. The remote interior angles are angle 1 and 2. All interior angles are 1, 2, and 3, and then angle 4 is an exterior angle. Now, for number 11, it says use a protractor to measure the angles 1, 2, and 4. For the sake of time, and since you may or may not have a protractor, I'm just going to give these measurements to you. Okay, so the measure of angle 1 is 85 degrees. The measure of angle 2 is 43 degrees. And the measure of angle 4 is 128 degrees. Okay. Number 12. What appears to be true about the measures of an exterior angle of a triangle in relationship to the measures of the two remote interior angles? Write a conjecture. This is known as the exterior angle theorem. It is corollary to the triangle sum theorem. So right now I want you to take a look at these three measures and figure out what you notice. Is there some sort of correlation between the three? So pause the video and see if you can figure it out. Hopefully you guys took this time and you realized that the measure of angle 1, 85, plus the measure of angle 2, 43, is actually equal to 128, which is the measure of angle 4. So the sum of the two remote interior angles is equal to the measure of the exterior angle. That is what we call the exterior angle theorem. Okay, so number 13 says complete the proof of the exterior angle theorem. So we made a conjecture, now we actually want to prove it, just like we did with the triangle sum theorem. You will use the triangle sum theorem to help you prove it. Okay, theorem, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Okay, so first we've got statement number 1, which is triangle ABC with exterior angle 4. And that is just what we're given. That's the image that we're given. Okay, statement 2 is asking for the triangle sum theorem, which we know from our previous proof is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Alright, statement number 3 says the measure of angle 3 plus the measure of angle 4 is 180 degrees. And we know that because if you look up here, they are a linear pair. Okay? And we know from our previous units that two angles that create a linear pair add up to 180 degrees. Okay? Statement 4 says that measure of angle 4 equals 180 minus the measure of angle 3. Well, all we did was take this equation up here and subtract the measure of angle 3. So our reason is the subtraction property of equality. That's why we can do that. Okay, so for this proof, we want to end up at the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So up here, we already said that 1 plus 2 plus 3 equals 180 degrees. And right here in our equation, we have measure of angle 4 is equal to 180 degrees, which we said is all three of these angles added together. Since I'm going to run out of room, I'm just going to go angle 1 plus angle 2 plus angle 3 and leave out the ends. And then minus the measure of angle 3. And how are we able to do that? Because of substitution. So now, if we actually do this equation, we have the measure of angle 3 minus the measure of angle 3. So these will just subtract out, and we have the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2, which is what we were trying to prove. And how did we do that? We simplified. Okay, so we just use this proof to prove the exterior angle theorem. Okay, go ahead and turn the page. Alright, we've got another example. The shaded piece of glass below is one of the triangles Jason needs to replace. Jason knows that this section of the glass, the measure of angle 2 is 3 times the measure of angle 1. So angle 2 is 3 times the measure of angle 1. Just labeling my image. And we want to figure out what are the measures of all the angles in the piece of glass. By the exterior angle theorem, you know that the measure of angle 1 plus the measure of angle 2 is 124 degrees. That's what we just proved. 1 plus 2 equals 124. You also know that the measure of angle 2 is 3 times the measure of angle 1, like we labeled in our image. So if we were to use substitution to find the measure of angle 1, we can say that the measure of angle 1 plus the measure of angle 2 is 124 degrees. And then we substitute in that 3 times the measure of angle 1 instead of angle 2. So we've got the measurement of angle 1 plus 3 times the measurement of angle 1 equals 124. We've now got 4 measurements of angle 1. And then if we divide both sides by 4, we've got the measurement of angle 1 is 31 degrees. Okay, now we can use that information to find the measure of angle 2. If we substitute in 31 for measurement of angle 1. We've got 1 plus 2 equals 124. We substitute this in right here. So we've got 31 degrees plus the measure of angle 2 is 124. If we subtract 31 from both sides, we get the measurement of angle 2 is 93 degrees. Now one way to find the measure of angle 3 is to use the triangle sum theorem. So if we do angle 1 plus angle 2 plus angle 3 equals 180, we just figured out that angle 1 is 31, angle 2 is 93, plus the measurement of angle 3 equals 180. If we subtract both of these things from both sides, we get that the measurement of angle 3 is 56 degrees. Okay, so now I want you to go ahead and pause the video and see if you can try and solve for the measurements of these angles. If the measurement of angle 2 is 10x plus 2, and the measurement of angle 1 is 11x minus 11. Okay, go ahead and pause the video right now. Alright, so hopefully you went ahead and tried to solve this. Okay, so we've got the measurement of angle 1 plus the measurement of angle 2 is equal to 138. That is the exterior angle theorem. So now I have these functions for angle 1 and angle 2, and I'm just going to substitute them in. So I've got 11x minus 11 plus 10x plus 2 is equal to 138. And now I just solve it like a regular equation. I combine like terms, my x, x, and a negative 11 plus 2. So then I've got 11x plus 10x, which is 21x, negative 11 plus 2, which is negative 9, is equal to 138. Add 9 to both sides. We've got 21x is equal to 147. Divide both sides by 21. And you get x equals 7. Okay, so now we know what x is, so if we want to find the measurement of these angles, all you have to do is plug x in. So for the measurement of angle 1, it's equal to 11x minus 11. So the measurement of angle 1 equals 11 times 7 minus 11. So the measurement of angle 1 is 77 minus 11. The measurement of angle 1 equals 66. And then we can solve for angle 2 one of two ways. One, you can put it in the exterior angle theorem, or you can plug 7 in for x and solve it that way. So the measurement of angle 2 is equal to 10x plus 2. Equals 10 times 7 plus 2. Measurement of angle 2 equals 70 plus 2. Measurement of angle 2 equals 72 degrees. And then we can use the triangle sum theorem to figure out the measurement of angle 3. So we've got the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180. We've got 66 plus 72 plus the measurement of angle 3 equals 180. Subtract both of these from both sides, and you get the measurement of angle 3 equals 42 degrees. Okay. So now I want you to go ahead and pause the video again and try and check your understanding. Work through 14, 15, and 16. So hopefully you work through these. Number 14 says, in an equal angular triangle, are all the measures of the exterior angles of the triangle equal? Explain. Yes, they are all equal, because if all three angles are equal, this would be 60, 60, and 60, anywhere that you draw an exterior angle, it should be 120 degrees, because it's always the two remote interior angles added together, which is 120. Number 15 says, is it possible for the measure of an exterior angle of the triangle to be equal to the measure of a remote interior angle? Explain. Well, because of our exterior angle theorem, we know that the measurement of one remote interior angle plus the measurement of another remote interior angle is equal to the exterior angle. So, by definition, an exterior angle measure is equal to the sum of the angles of the measure of its remote interior angle. If an exterior angle measure were equal to one of its remote interior measures, then the measure of the remote other one would have to be 0. So if this was, 72 plus another measure has to equal 72, this would be 0, and then it's no longer a triangle, and it's not possible. Okay, and number 16 says, if the measure of two angles of a triangle are equal to the measures of two angles of another triangle, what can you conclude about the measures of the third angles of the triangle? Well, if you have two triangles, and this is 50, and this is 60, you've got the same thing in two different triangles, 50 and 60. We know that it has to add up to 180 degrees, so this is always going to have to be 70. And same for the other triangle. This is always going to have to be 70. So that third angle has to be equal as well. Okay? So again, we're going to do the lesson 3-1 practice. So I'd like you to pause the video and work through 17 through 23. We'll come back when you've finished. So I've gone ahead and done 17, 18, and 19. For 17, we're trying to find the measure of angle 1. The measure of angle 1 is going to be, we're going to use the exterior angle theorem, where angle 1 plus 90 degrees equals 125. Then we just subtract 90 and we get the measurement of angle 1 is 35 degrees. For 18, we're trying to figure out the measure of angle 2. And we can use a linear pair. These two are linear pairs. So the measure of angle 2 plus 125 has to equal 180. Subtract 125, we get the measurement of angle 2 is 55 degrees. Now for 19, it says that two remote interior angles are 37 and 62. We add them together, we get 99. And then for the third angle, we just do 180 minus 99 and we get 81 degrees. Lastly, all we do is solve for x and then we plug it in to find the last three. Good job, that's the end of this